Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have a to the power of 4 minus 16 is equals to 0, and we solve this problem for all the values of a. You see that the highest degree of this equation is 4. It means that this equation has 4 or less than 4 roots. We need to find all that roots of this equation. So here first we rewrite this equation as this is a to the power of 4, and we write it as a square and its whole square minus this is 16, we write it as 4 square, and this whole equation is equals to 0. And further in the next step we need to simplify the terms, and here we use the nice algebraic formula. You know about that. If we have x square minus y square is equals to x minus y times of x plus y. So according to this nice rule, we just apply here this nice formula to the above equation. So after applying this formula, our above equation is written as the first factor is x minus y here, and the base of this term is our x, and the base of this term is our y. So we have the value of x is a square minus the value of y is 4 into again the value of x is a square, the value of y is 4, and this whole equation is equals to 0. And now we break this equation into the two cases. The first case is we write a square minus 4 is equals to 0, and the second case is we write a square plus 4 is equals to 0. So here we again rewrite this equation as a square minus we write 4 as 2 square, and this whole equation equals to 0. And now we again apply this nice formula, and according to this formula this equation is written as in this form. Now here we have a minus 2 times of a plus 2, and this whole equation is equals to 0. We again break this equation as a minus 2 is equals to 0 and a plus 2 is equals to 0. From this case we easily get the value of a is equals to plus 2. This is the first real root of the given equation, and from here we move plus 2 to the right hand side and we get a is equals to minus 2. This is the second real root of the given equation. So for here we get these are the two real roots, and now we need to copy down this equation here. If we rewrite this equation as a square is equals to, we move plus 4 to the right hand side and we get a square is equals to minus 4. So here for the values of a we need to remove this square sign, and we take square root on both of the sides, and when we apply square root it will be written as this 2 and this square root are gone, and we get here a is equals to, here we break this square root sign and we apply square root separately on both of these two values, and we get here square root of 4 into square root of minus 1. Further, you know about that when we apply square root on both of the sides, we write here plus minus sign on any one of the sides. So we get here a is equals to plus minus square root of 4 becomes 2 into square root of minus 1 becomes here iota. So these are the other two complex roots of the given equation. So you see that we have these are the four roots of the given equation which we get here in this method. And now in the next steps we need to verify that is these roots be the solution or is these roots be the extraneous root. So for verification of this we need to copy down given question statement here. It is a to the power of 4 minus 16 equals to 0, and in this side we will be verify a is equals to plus minus 2, and in this side we will be verify a is equals to plus minus 2 iota. So we verify all these four roots of the given equation. And now first we focus on a is equals to plus minus 2. So we substitute a equals to plus minus 2 into the left hand side, and it will be written as plus minus 2 to the power of 4 minus 16 is equals to 0. Here you know that when and the exponent is an even number, so it always gives us the positive answer. This means that the negative term becomes here into the positive form, and we just get 2 to the power of 4 minus 16 is equals to 0. Further, we know that 2 to the power of 4 becomes 16 minus 16 is equals to 0, and we get here 0 equals to 0. This shows that the value a is equals to plus minus 2 satisfied our given question statement. And now in the same pattern we need to verify the other values of a, so that we substitute this value of a into the left hand side of the given equation, and it will be written as plus minus 2 iota and its whole power 4 minus 16 is equals to 0. And further we just again break this base and we write it as plus minus 2 to the power of 4 into iota to the power of 4 minus 16 is equals to 0. Again, you know that the base is the exponent is an even number, so it will always gives us the positive answer. And we have 2 to the power of 4 becomes 16 into, here you see that iota to the power of 4 we write it as iota square and its whole square minus 16 is equals to 0. And in the next step we need more simplifications here, and we get 16 times iota square is equals to minus 1 and its whole square minus 16 is equals to 0. You know that minus 1 square becomes plus 1, and we get 16 minus 16 is equals to 0, and we clearly get here 0 equals to 0. So again, both of the sides are equal. It means that all four roots of the given equation are satisfied our given question statement. So finally we have the solution set of the given question is plus minus 2 and plus minus 2 iota. So this is our final answer, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.